All right, this lesson's about exponents. All right, so when we have a number 8, and if we want to write that in exponential notation, that would be this right here, 2 to the power of 3. Or you can say 2 to the third power. Now an exponent is this number right here. All right, it is telling us how many times this number, which is called the base, is multiplying itself by. All right, so when we see 2 to the power of 3, it's saying the number 2 is going to multiply by itself 3 times. So 1, 2, 3. And if we work this part out, we would get 2 times 2 is 4, and we would get 8, which is what we started with. Now, one of the properties of exponents is when you are multiplying 2 of them together, you can simply add the exponents if the base is the same. So both base are 2, so we can simply add the exponents together and we get 2 to the power of 6. Right? And we can confirm that by expanding it and seeing, okay, if I expand this, I get 2 times 2, right? And I expand 2 to the power of 4, I get 2 times 2 times 2 times 2, all right? That completely together, if I take away the parentheses, I am multiplying 2 by itself 6 times, which is the same thing as 2 to the 6. Right, which is the same thing as just adding the exponents together. All right, so we can completely skip these 2 steps, go from here straight to here by using this property. All right, now that also helps us understand what 2 to the 0 is. All right, and if you ask your student, they can probably tell you right away what these are. 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. Now if I ask them what the 2 to the power of 0 is, a common mistake is to say 0, because they see the 2, they see the 0, they think multiply, they get 0. Okay, so that's not a bad line of thought. Now 2 to the 0, 2 to the power of 0 is not 0, it is actually 1. And we can prove that by using the property. So if we were to add, let's say 2 to the third power, multiply that by 2 to the 0 power. Okay, the property says we can simply add the exponents and then we get 2 to the third power. All right, now if we expand it, that will expand to 2 times 2 times 2. All right, and then we are trying to figure out what would this equal to. Now, 2 to the power of 3 is 2 times 2 times 2. And we know that these 2 are equivalent. All right, so that means these 2 in expanded form should be equivalent. So what number can we what number can we multiply with and not change the number? Well, there's only one number that would qualify, and it's number 1. So it would make sense that 2 to the power of 0 is 1. All right, so if they have the easiest way is just to memorize that 2 to any number x to the power of 0 equals 1. But if they forget that, they can still figure it out using the property. Now, when we deal with exponents that have to do with the number 10, there are some unique qualities of it that we could take advantage of and be able to figure it out a lot quicker. So we know that any number to the power of 0 is 1. Right? Any number to the first power is just that number by itself. Right? And now 10 to the power of 2 is 10 times 10, which is 100. 10 to the power of 3 is 10 times 10 times 10, which is 1,000. And then we can begin to see a pattern here. Whatever the exponent is, if the base is 10, we can simply just add in the zeros, the same amount of zeros at the end. because that's the characteristics of when we multiply by 10. All right, so if we get a big number like 10 to the 12, we simply have 12 zeros here. All right, and then further, and we can go a little further and apply that to place values, which is the last, well, second to last section of the lesson, right before the order of operations. So when we talk about place values, we're talking about, so if we have a number like 3,124, okay, that's the ones place, that's the tens place, the hundreds, and then the thousands. We can expand this into 3 times 1,000 plus 1 times 100. All right, now we rewrite that. So 3 times 1,000 plus 1 times 100 plus 2 times 10 plus 4 times 1. So we got the ones place, the tens, the hundreds, the thousands. It corresponds to what we know about place value. Okay, now we can go ahead and go even further and change the 1,000 and write it in exponential notation, which is 10 to the third power. And then we got 1 times 10 to the second power, and then 2 times 10 to the first power, and then lastly 4 times 10 to the 0 power. Remember, 10 to the 0 is 1. All right, so this is expanded notation of the number 3,124. All right, now there's not going to be very many instances where you need to go from here to here, other than if the question specifically asks you to. All right, but the point of understanding this is if you were given a question like this, and you were to find out what is this number, instead of working it out, right? So if you look at the notes, it's kind of like we're going backwards. So we'll find out what 3 times this is, and then we find out what this is, what this is, what this is, and add them all together. All right, that'll take some time. Instead, we can see, because we're talking about exponents with the base of 10, all right, it corresponds to the place value. So right away I can see, okay, 10 to the third power, that's the thousands place. So we have ones, tens, hundreds, thousands. That means whatever number I'm multiplying that by, that goes in the thousands place. And then that would go into the hundreds place, tens place, and then the ones place. And I would get 3,124 a lot faster than if I had to work out each individual step. All right, so another example would be, let's say 5 times 10 to the power 4 plus 3 times 10 to the power 2 plus, let's go, 2 times 10 to the power of 0. Okay, so I would look at the highest value for the exponent, which is 4. All right, and that means that is the most places I'm going to, which is the 10,000th place. Okay, since it's multiplied by 5, I'll get a 5 there. All right, now the thousandth place, which is 3, 10 to the third power, is absent. That means there is no number there. And move on to the next one, which is 10 to the 2, 10 to the power of 2, that would be a 3. All right, 10 to the power of 1 is absent, so that's a 0. And then lastly, the ones place, we have a 2. All right, so I can not immediately, but a lot faster get the answer 50,302 instead of having to work out each step. All right. Now, the last part of the lesson is using the order of operations, including exponents, and we'll be able to explain that with just using the homework examples. Okay, for 1A, we are to expand and compute the answer for the following expressions, and then decide which is greater. So we have 5 to the power 3 and 3 to the power 5. All Alright, so first we gotta expand. 5 to the power 3 is 5 times 5 times 5. Remember, the exponent 3 tells us how many times the base, which is 5, is multiplying itself by. Alright, and then to expand 3 to the power 5, you're multiplying 3 by itself 5 times. Okay, and now we just have to find out what each of these are and then compare the two, see which one's greater. Alright, so to work out 5 times 5 times 5, I would go in order. So 5 times 5 gives me 25. Alright, and then 5 times 25 is 125. Alright, you can work it out to the side if you need to, if you can't do that in your head. Alright, and then over here, again, do one at a time. 3 times 3 is 9. Right, and if it helps you, you can even draw parentheses that kind of reminds you I'm doing this first, and I have these left. Okay, and then go ahead, do the first two again. 9 times 3 is 27, and I got 2 more left. Alright, keep going. 27 times 3, that gives me 81. Right, and again, if you need to, you can work it out on the side. I'm not going to do that. And then last, 81 times 3 is 243. Okay, and then 243 is clearly greater than 125, so 3 to 5 is greater than 5 to the power 3. Okay, number 2. We are simply just evaluating the expression. Okay, so we start out with 2 to the power 3. Alright, remember that's the same thing as 2 times 2 times 2, and then we have a plus 2 after that. Alright, and then we multiply before adding, so 2 times 2 is 4, and you can always add parentheses just to remind you that's what you're doing first. Alright, again, multiply before adding. 8 plus 2, and then finally 10. Alright, so 10's our answer. Okay, number 3. Supposed to evaluate the following expressions again, except this time it gave you 2 separate ones. Alright, and the point of the question is to show you that these two are actually equivalent. Alright, by using the rule from the lesson, we know that we can, if the two bases that are multiplying by each other are the same, you can simply add the exponent. So 3 plus 4 will give me 7, so this is equivalent to 2 to the power of 7, which is the other one it gives us. Alright, so if you find one, you'll automatically find the other. Right, now it's just up to you how you want to do that. Alright, now both will equal to 2 times 2, 7 times. Okay, and you can always just go left to right, do this one first and the next one and the next one. Or if you're capable, you can do it by grouping. You can find out what this is, and then that may be a faster way. Alright, but I'm just going to do it the least confusing way, which is just go in order. Alright, might take a little longer, but I know I won't mess up if I do it this way. Alright, again, the parentheses will help me, especially on one that's this long. The parentheses will help me to remember I got 1, 2, 3, 4, 5 left, so I still need to multiply by 2, 1, 2, 3, 4, 5 times. Alright, then we got here. Alright, I'm just gotta keep on going. Since I'm kind of running out of room here, I'm going to go ahead and work it to the side. Alright, so the answer is 150. 128. And again, if you want, from here, you could possibly find out what these are, right? And that'll give you 4 times 4 times 4 times 2, right? And then you could go by grouping again, and you would get 16 times 8, right? And from there, it's possibly that you can get 128 faster, right? So if you look, we had 1, 2, 3 steps to get the answer, whereas the first method, 1, 2, 3, 4, 5, 6 steps. But again, you would have to have a good understanding on how to group these to do that. All right, so multiple ways, is just whichever way works for you. All right, number 5. I'm going to go ahead and give you a second to read the question. You can pause the video if you need more time. Right, but basically Rhonda has one sheet of paper and she's going to cut it into thirds and then stack the paper and then complete this process 5 times. Alright, so I'll try to draw this. So a sheet of paper, she's going to cut it in thirds. Okay, so if you imagine this sheet of paper, she's going to cut it probably this way and then take the individual pieces and stack them up together. Right, so this paper, you're going to have basically 3 smaller pieces and then you're going to stack them, so it's going to look like that. Okay, and then I'm going to just kind of expand that a little bit and draw that a little longer. I'm blowing it up a little bit. So those are my 3 stack of papers, and that's after cutting it once. Next time I'm just going to do the process again, except this time when I stack, I already have 3 and then another 3 and then another 3, so now I have 9. Okay, and then as you can see, as we continue the process, more and more people will be added and it's going to increase exponentially. Alright, so we probably need to express this in the form of an exponent. Alright, so since she is doing this 5 times, and each time we have 3 pieces of paper, it would make sense that 3 to the power 5 would probably get us our answer. Alright, so to find that out, we just gotta find that. Okay, now instead of working it out, I can just go back to first question. We already found that out. 3 to the power 5 is 243. Alright, so 243 is your answer. There's going to be 243 sheets of paper. Alright, for number 7C, we are to use order of operations to simplify this expression. Okay, so we go down our list. There's no parentheses, so the next one we're looking for is exponent, and we have 3. Alright, so we need to figure out what the exponents are first, and 10 to the second power is 100 because it's 10 times 10. 10 to the first power is simply 10, and then 10 to the 0 power is 1. Alright, now we're left with multiplication and addition. Okay, and we're supposed to multiply before adding, and this is just something I like to do. Adding parentheses will just help me visually see that I'm supposed to do those first and then don't add anything yet. So 3 times 100 is 300, 7 times 10 is 70, 8 times 1 is 8. Now I can go ahead and add, and since they're both adding, I just simply go left to right. So 300 plus 70 is first. You can add in parentheses just in case. Alright, so that will give me 370. And then the last step, 370 plus 8 is 378. Alright, now that's the straightforward way. There is a faster way to do this, utilizing what we know about powers of 10. Alright, back to the lesson, we talked about how the powers of 10 coincide with our place values. Alright, this is the ones place, this is the tens place, and this is the hundreds place. Alright, so knowing that, instead of working everything out, I know that whatever number multiplied by the hundreds place, that's where that number will go. Right? In tens place, we're multiplying by 7. The ones place multiplying by 8, we get 378. And you can see how that is a whole lot faster than working it out. All right, but if you don't understand that, that's something, you know, either they forgot or are a little confused about, you can still use order of operations and get the right answer. It just takes a little bit longer. Moving on to number 8, I'm not actually going to solve this. I'm going to let the student do it themselves, but in case they get an incorrect answer, looking at what we have addition, multiplication, remember we have multiply right there in between, division, and then an exponent. All right, and actually in parentheses too. Okay, so even though exponent comes before division, you have it, since it's in parentheses, you got to do that first. So find out what 9 divided by 3 is, then go ahead and apply the exponent, and then multiply by 5, and then last you add the 5, and that should give you the correct answer. I'm going to go ahead and explain number 12 too, since it's pretty much the same thing as number 8. Alright, same thing, I'm not going to actually work it out, but if they did get it wrong, you're supposed to apply the exponent first. Alright, find out what 8 to the power of 2 is. Then you go ahead and multiply it by 7, then divide it by 2, and then lastly add the 10. And that should give you the correct answer. Alright, now number 9. This is a similar problem to number 6, except, oh, sorry, not number 6, number 5. Alright, but it's also a little bit different. Okay, so I'll give you a second to read the question, pause the video if you need more time. Alright, but it is saying that there's 6 students and they're eating candy. The first student eats 1, and each student after that must eat 5 times as many as the person before them. Alright, so you can see that it's going to increase exponentially because it's going to, whatever the previous amount is, going to be multiplied by 5 each time. Now the difference is the first student's only eating 1, whereas back to number 5, once we did the first process, cutting paper, you get 3 right away. Okay, so the first person is only eating 1, and then the second person will then eat 5 times, and the third person will eat 5 times, and the fourth person 5th, and the 6th. So then you can see we're actually only multiplying 5 by itself 5 times instead of 6 because there are 6 students. Okay, so the answer is actually 5 to the 5th power and not the 6th power. Okay, so that is the difference there between the two questions. Now another way you can look at this is the first person, right, is eating 1, which is 5 to the 0 power. The second person in turn is eating 5 to the 1st power. Third person would be eating 5 to the 2nd, alright, and so on and so forth. And eventually you get to 5 to the power of 5. Alright, so the answer is 5 to the power of 5. Go ahead and you can work that out and you will get your answer. Alright, but the main thing is understanding what the question's asking. You know, number 9, the first person is only eating 1, right? And compare it to number 5, the first time you're doing the process, you get 3. So right away, you're not starting with the 5 to the 0. You're starting with 3 1 and then 3 2. Alright, so that's why the answer is a little different if you're trying to do it quickly. Alright. Number 14 is the last homework question. That's another order of operations. The answer key explains it pretty well, so I'm not going to do that.